Okay, let us see this number and we see how we can use also the principle of conservation of energy, which says mechanical energy is equal to the potential energy plus the kinetic energy, and the potential energy, the mechanical energy, is always the same at any point. So let us go through the question here. It says a particle P of mass 6 kilograms is suspended from a fixed point C. So let me start by putting a fixed point C here. So this is my fixed point C. By a light out string, light means its weight is negligible, or 4 meters long. The particle is projected from its lowest position A, the lowest position is here. So if this now our string is fixed there, is projected at this lowest position, so this is going to be our A. Of course, they're telling us that this string is 4 meters long. So they are giving us, they are giving us the length of the string as 4 meters. They are also giving us the mass of the particle as 60 kilograms. They are also giving us whenever they talk about the resultant velocity, they are talking about the initial velocity, which is U, as 8 meters per second. Basically, that's what we have. But we also know that our L is equal to the radius equal to M. So if you project a particle like this and this is the string where it's touching, it means that that's going to be its radius in actual sense. If this is the particle, so from here up to here is the length of the string. It means that now when I'm projecting it like this, the circle I'm going to form, the length of the string, you see that it's going to be the radius of that circle being formed. So that's the idea we have there. So that's the case. Now I'm going to say, you're telling me that at this whole point A with the velocity U 8 meters per second. If the angle SCP means that now the particle is moving somewhere, is 60, find the speed of the particle P. So this is the case we have. So I'm going to consider that this is where my particle is now, the particle P. And we, of course, it's going to be still having the weight. Weight is given by the mass times V. Of course, we're going to be having tension in this string. Now, that's the case. This angle ACP, they are telling me it is 60 degrees. So that's the case we have first of all. Now, they want me to get the velocity. They want me to get the velocity here. So the velocity here is going to be V meters per second, and the velocity here is U meters per second, which is the gave us as 8 meters per second. So that's what this projection. So what we do first, we resolve this force, this weight here, and then resolving that weight, that will be the way I resolve. This angle is going to be the same angle there as 60. So this is going to be now 6G, then cos 60. Then this is going to be 6G sine 60 degrees. So that's the case we are having. Now, the distance it would have covered from here up to here, the vertical distance, this is the vertical distance here. It has covered from here up to here. From here up to here, it's the vertical distance it has covered. So this is the length or the radius from there up to there. It's 4 meters. So now I'm going to show you two methods of getting this. I'm going to first use the method when you use the linear, when we use the equations of motion, and I also show you the idea of the kinetic energy and potential energy. So method 1. This is my method 1. I'm going to show you here. Okay, so if you need this final velocity, we always know that RV squared is always equal to U squared plus 2AS. Now these are linear equations, so meaning we need the vertical distance covered. From here to here, the distance covered is the one from here up to here. So that means that now I need, first of all, my acceleration is going to be negative g, and then the distance covered. And now these are linear, so we deal with lines, not curves. So that's how my S, H is going to be equal to H. Now the task is to get this H first. So let me consider this, consider a sector, consider a sector. So now let me consider this sector here. Let's see if I pull out that sector. In that order, I think everyone can see that is my sector. So that sector there, I think you see this is the height I'm interested in. From here, up there is the height I'm interested in. But I know that from here, up here is 4 meters, up down there. And the same this is also going to be 4 meters. Because from here up here is radius, from here up here is radius. So that's why that is also 4 meters. So this angle here is 60 degrees. So if I have this angle, it means that I can get this length from here up to here. So meaning from there up to here, it's going to be 4, then cos 60 degrees. So meaning I can get this h by saying my h is going to be 4, the whole, then minus 4 cos 60 degrees. But I know that cos 60 the same as a half. From there is that my height is going to be 2 meters. When you put here a half, you get 2, 4 minus 2, you get that. Now from there, I come and I substitute. Now they gave us that the velocity here, our u, is 8 from there. So putting everything here, my v squared is going to be u squared minus, first of all, 2d, now h, because my h is s. My acceleration is negative. It's acting against gravity because it's moving in that order. So here my v squared is going to be u, which is 8 squared minus 2, then times 9.8, then times 2. So from here my v squared is going to be, that is going to be 64 minus 2 times 9.8 times 2. So this is going to be 24.8, and then the square root will be 4.97. This is going to be 98 if I round off meters per second for the small places. Now this is the velocity at this particle there. So this is method 1. I think it's the cheapest. Now, if you look for method 2, use here principle of conservation of energy. Conservation of energy. So it's up to you. The one which is simple for you is what you are going to use. So consider that A. So remember, our mechanical energy is equal to the kinetic energy plus the potential energy. So I'm going to consider the kinetic energy at the moment, the mechanical energy at A, then the mechanical energy at B. So we say at A here, you can see that at A, our kinetic energy, I think you see the formula. Okay, our KE is always equal to half mv squared. Then our potential energy is given by mgh. So these are the formula we are going to apply here. So at A, it's that our velocity at A is this. So you have a half times the mass 6, then times 8, the whole squared. So our kinetic energy at A here, you see it's going to be 3 times 6, therefore, which is 192 joules. So when you come to our potential energy, which is mgh, you see at A, height is 0. Here our height is 0, implied that our potential energy is going to be 0. So now our mechanical energy is going to be 0 plus 192, which is going to give us the mechanical energy at A as 192 joules. So now, after that, we come at P. At P. So if we come at P, is that now our kinetic energy at P is going to be a half times the mass, then times the velocity is what we are looking for because we don't have it. So b squared is that, which is going to give us 3b squared. Then our potential energy at P is going to be now mgh, VH, which is 6 times 9.8. Now times, we have the height. Now at P, we have this height H, which we got as 2. So you see that this one is going to give us 117.6 joules. Meaning that now my mechanical energy, I think we know kinetic energy plus potential energy. So I'm going to get 3b squared plus 117.6. So this is the mechanical energy at A. So meaning M mechanical energy at A is equal to mechanical energy at P. So that is the idea. So now we are going to be adding 192 equaling to 3b squared plus 117.6. And so my 3b squared here is going to be as 74.4 and divide by 2, by 3, I'm getting 24.8. So my V is going to be root answer 4.98 meters per second. So the answer is also there. So I think you can see the same answer. So either use this or use this. All of them are going to give you the same answer. Anyway, that was by the way, use one method. So part B, they want us to get a tension in a string. So it's not our tension in the string, this is our tension in the string. So if you resolve in this order, know that always using Newton's second law, the resultant force is equal to the mass times the acceleration. What's our resultant in that direction? You see T minus this. So T minus 6b cos 60 degrees is going to be equal to the mass times the acceleration. Our acceleration always in circular motion is v squared over r. So this is going to be T minus 6 times 9.8 times a half cos 60. So it's a half is equal to r minus 6 times r v squared. Our v squared, I think we see 24.8. The whole over our r is 4. So from here my T is going to be, now when you simplify the other side, times 6 divided by 4. So you have 7.2. Then plus, when I take this side, I have 3 times 9.8. So my tension is going to be now 66.6 newtons. So it's up to you, everything forward. So that's it. Either use this method or use this method. Everything is going to give you, we are going to get the same answers. It's up to you. Work is there. That's it, but please don't forget to subscribe to the channel or visit the playlist. There are many having all these topics. See you in the next lesson.